and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about neutralization reactions. Our aim for today is how can we construct a neutralization reaction? But first, let's talk about amphoteric substances. The word amphoteric means a substance that can act as both an acid and a base. The prefix ampho means both. For example, an amphibian can live both on land and in water. Both. An amphoteric substance can act as both an acid and a base. One example, water. Water is amphoteric. Whether it is an acid or a base is dependent on what other substances are in solution. For example, when HF dissolves in water, water acts as a base. Let's take a look. HF, hydrofluoric acid, is obviously going to be the acid, plus H2O. Well, in this case, the acid, according to Bronsted-Lowry theory, is going to donate an H plus to the H2O. So as a result, we're left with F minus plus H3O plus. So in this example, water is accepting the H plus ion, so it is the base. And if we were to finish this off, the acid becomes the conjugate base, and the base becomes the conjugate acid. Once again, water acts as a base when it is with hydrofluoric acid, when it's with an acid, because it accepts an H plus ion. However, when water is with NH3, so if you have NH3, which is a base, it's ammonia on table L of your chemistry reference tables, plus H2O, H2O is going to act like an acid because the H2O is going to donate an H plus to the NH3. As a result, we get NH4 plus, and we lost an H plus, so we're left with OH minus. So once again, we have NH3, which is the base, which goes to the conjugate acid. And the acid, H2O in this case, once again, it's donating an H plus, becomes the conjugate base. Okay, so back to neutralization reactions. A neutralization reaction is a reaction in which an acid and a base in aqueous solution react to produce salt and water. Water is always going to be H2O, but the salt will change based on the different types of acids and bases coming together. A salt, of course, is an ionic compound made up of a cation, which is a positive ion, from the base, and an anion, a negative ion, anion, from an acid. And remember, a neutralization reaction is one specific type of double replacement reaction. Let's take a look at some examples. For the first problem, we have HCl, which is hydrochloric acid, obviously an acid, and we have NaOH, sodium hydroxide, which is our base. When these two come together, when they react, they will neutralize each other. So they will form water. Remember, water is always a product of a neutralization reaction. So let's write that first. For any neutralization reaction, the first thing that we should write is H2O, because you will always get a water. How does that work? Well, this H and this OH come together to make H2O, which means we're left with Cl and Na. Now, when we write an ionic bond, when we write the formula for the salt, we always put the cation, or the positive ion, first. In this case, it's sodium. Sodium is a group 1 metal, so it has a charge of positive 1. Then we write the chlorine second. Chlorine is in group 17, so it has a charge of negative 1. We perform the crisscross drop swap method, and we get an A1, but we don't write the 1, and Cl1, but we don't write the 1. Let's rewrite. H2O, HCl on this side, plus NaOH goes to H2O and HCl. Let's check to make sure our equation is balanced. H, we have 1 plus 1 is 2. Cl, we have 1. Na, we have 1. And oxygen, we have 1. On the right side, H's, we have 2. Cl's, I like to keep the same order. Cl's, we have 1. Na, we have 1. And O, we have 1. So this equation was already balanced. We didn't have to do anything. So this is our final answer. HCl plus NaOH goes to H2O plus NaCl. This is our first neutralization reaction. This second problem is a little bit trickier. We have magnesium hydroxide, MgOH2, which is our base, reacting with HNO3, nitric acid, which is of course our acid. When these two substances react, once again, it's a neutralization reaction, so we're going to get water, this H and this OH. Now there's two OHs, but we'll worry about that once we balance the equation at the end. So when this H and this OH comes together, we make water. So H2O plus, let's look what's left. We have magnesium and we have nitrate. Plus, magnesium is the cation, so it comes first. Now magnesium is in group 2 of the periodic table, so it has a charge of plus 2. Whereas nitrate on table E has a charge of minus 1. When we crisscross drop swap for this equation, we get Mg1, we don't write the 1, parentheses NO3, 2. Always put the polyatomic ions in parentheses. Let's finish rewriting. H2O, there's our arrow, HNO3, nitric acid, and magnesium hydroxide, MgOH2. Now this one is not balanced. Let's write down our elements. Magnesium, there's 1. Oxygen, I'm only going to worry about this oxygen. I'm going to keep this nitrate together as a polyatomic because it appears on both sides. So nitrate here on the left side, I only have 1. Back to oxygen, 1 times 2 is 2. And for hydrogen, I have 1 times 2 is 2, plus 1 times 1 is 1, 2 plus 1 is 3. So on the left side, I have 1 magnesium, 2 oxygens, 3 hydrogens, and 1 nitrate. On the right side, let's keep the same order. Magnesium, I have 1. Oxygen, once again, I'm going to leave this nitrate, the oxygen and nitrate alone. I have 1 oxygen here. Hydrogen, I have 2. 1 times 2 is 2. And nitrate, NO3, I have the 2. So magnesium's already balanced. Oxygen is not balanced. I have 2 on the left, 1 on the right. So if I put a 2 here in front of the H2O, that changes the number of oxygens. 2 times 1 is 2. And it also changes the number of hydrogens. 2 times 2 is 4. I also need to fix the number of nitrates. I have 2 nitrates here, 1 nitrate here. Easiest thing to do would be to put a 2 right here. So that also changes the hydrogens. Let's do the nitrates first. 2 times 1 is 2. Now let's take a look at the hydrogens. 1 times 2 is 2, plus 2 times 1 is 2. So I have 4 hydrogens on the left. 1 magnesium, 1 magnesium, 2 oxygens, 2 oxygens, 4 hydrogens, 4 hydrogens, and 2 nitrates and 2 nitrates. So this is our final equation. I'm going to rewrite this on the bottom. So we have MgOH2 plus 2 HNO3s. That's going to go to 2 H2Os plus 1 MgNO3, 2. And this is our final balanced neutralization reaction. Let's try one last one together. Barium hydroxide and sulfuric acid. Now, we're not given any formulas for either the acid or the base. So let's write them. Barium hydroxide, which is our base. We have barium, which is a group 2 element, which means it has a charge of positive 2. You can see that on the reference table. Hydroxide, which is OH minus. We're going to put that in parentheses. And sulfuric acid. Nice and easy. That's on table K. That's H2SO4. So when we do crisscross drop swap, we get BaOH2 plus H2SO4. That's going to yield, it's a neutralization reaction, so we're always going to get a water. These H's and these OH's come together to make water. So we're left with barium and sulfate. We'll take care of the balancing later. So barium, once again, has a charge of positive 2, and sulfate has a charge of negative 2. When we crisscross, drop swap, we get Ba2SO42, which just reduces to BaSO4. Let's write it over. H2O. We have our arrow, H2SO4, and BaOH2. If we were to balance this, we have Ba, there's one of them. Oxygen, there is, we'll leave the sulfate by itself, SO4, there's one of them here. The oxygen, so 1 times 2 is 2. And hydrogen, 2 times 1 is 2, plus 1 times 2 is 2. So there are 4 hydrogens on the left side. On the right side, we'll keep the same order. So for barium, there is one of them. For oxygen, once again, we're going to leave the sulfate by itself. And there's 1 sulfate. For oxygen, there is 1. For hydrogen, there is 2. Now we balance 2 oxygens on the left, 1 on the right. So let's put a 2 here. 2 in front of the H2O. So now we have 2 oxygens, and 2 times 2 is 4 hydrogens. And it looks like we're already balanced. 1 barium, 1 barium, 2 oxygens, 2 oxygens, 4 hydrogens, 4 hydrogens, and 1 sulfate, 1 sulfate. So the last thing we do is rewrite the equation. Barium hydroxide, BaOH2, Please make sure you keep the hydroxide in parentheses because there's two O's and two H's. If you get rid of the parentheses, that means there's just two OH's. Plus 1 H2SO4 goes 2 yields, 2 waters, 2 H2O's, plus 1 barium sulfate, BaSO4. Then we have our balanced neutralization reaction. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned about how to write and balance a neutralization reaction. Remember, when an acid and a base react and neutralize, the byproducts are going to be water, H2O, and a salt, an ionic substance. Thank you again. I hope you learned something today. Please join us again soon.